Right. So in the last class, we have discussed all the basic programs using the for loop. And today we are going to discuss about a few more examples like a sum of first n numbers. First n numbers is nothing but, suppose if n value is a 5, consider 1 plus 2 plus 3 plus 4 plus 5. Output should be 15, like this. Okay. Now in this one, so first we are asking, taking that n, and we just ask enter n value. Enter n value. We are just reading the n value. After reading the n value, we need to find the sum. First of all, we have to repeat the loop. Loop starting from 1, but ending with not 5. Very, very important one. It's not ending with a 5. If n value is 6, we should repeat up to 6. If n value 10, we should repeat up to 10. Okay. So like this, we are repeating. Like this, so we are repeating. Now observe this. In this one, 1 to n we have to repeat. Declaring the I variable, repeating the for loop, I value starting from 1, I less than or equals to n, I plus plus, n times we have to repeat that loop. But every time 1, 2, 3, 4, 5, each value you are adding to the sum. Like sum is equals to sum plus I. Outside printing sum of first n numbers. Look at this. Let me explain more clearly this one. Repeating the loop up to n. So nothing but if n value 5 is repeating up to 5. We are taking one extra variable sum. Here we declare that sum variable, sum value starting with 0. Then I value every time you are adding to the sum. 1 we are adding, 2 we are adding, 3 we are adding, 4 we are adding, and 5 we are adding. Every time you are adding to that sum. First, for 0, 1 we are adding. 0 plus 1, 1. Next I value become 2. 2 will be added. 1 plus 2, 3. Next I value become 3. 3 will be added. 6. Next I value become 4. 6 plus 4, 10. Next I value 5. Become 15. This 15 will print in this place. Okay. So taking one extra variable like sum equals to 0, then adding. So when you run the code, if you give that input is a 5, output is a sum of first 5 numbers is a 15. Please write the code fast. Okay. So sum of first n numbers means what? We are taking one variable sum. Here it is. We are finding the sum by repeating that loop and printing. In the same way, the next one is factorial. Factorial of n. See the simple one. If n is equals to 5, n equals to 5, you just multiply 1 into 2 into 3 into 4 into 5. 3 into 4 into 5. Of course, 5 into 4 into 3 into 2 into 1 also will give the same result. Okay. Just take one variable, fact. Any variable name you can use, just fact I am taking. We are asking to enter the n value. Loop repetition is same, starting from 1 to n. Is a fact is equal to fact is multiplied with I. But see, when you use a multiply, don't initialize with a 0. Initialize with a 1. Why? Because when you multiply any number with multiplied with 0, final value becomes 0. So make it 1. Make it 1. And just giving that factorial of n is a fact value. This n value will print here and this fact value will print here. Okay, sir, here just 1 into 2 into 3 into 4 into 5 as well as 2 into 3 into 4 into 5 will give the same result now, because 1 into is the same result. So I can skip 1. I can start from 2. We'll get the same output only. No problem. If 5, output is 120. 5 factorial output is a 120. Okay, please do this. Factorial of the given number. Okay, now see here, I just want to print multiplication table. Multiplication table is the same one. I'm asking to read the table number enter table number. Suppose if they enter 7, 7 is multiplied with 1 equals to 7. 7 is multiplied with a 2 is a 14, and so on. 7 is multiplied with a 10 equals to 70. Like how many times we have to repeat the loop? 1, 2, 3, and so on up to 10. So I value we are repeating. Look at this. I value starting from 1, I less than or equals to 10, because we repeat the loop 10 times. I plus plus. Inside only formatting is important. Printf percentage d, this one 7777. For this percentage d, 7 means table number n. Just an example I have taken 7. Next, look at this. Multiplied with percentage d is a 1, 2, 3, 4, and so on 10 is I. Next, equals to percentage d. This means what? N into I. N into I. Here table number, here I value, here N into I value. N into I. So when you are executing, any number you can give. Let me give 23. Look at this. 23rd table is printing. The given table number is printing. Is a multiplication table. Okay, please write. See here, I just want to display 3 programs I will write. Look at this. Print even numbers only. Evens from 1 to 10. 1 to 10. So just loop repetition from 1 to 10. Only loop repetition from 1 to 10. /n, /n, just printing that I. 1 to 10, when you run, each value is a printing. Each value. Look at this. 1 to 10, all values are printing. But I need only even. So condition I am writing. Now if block with the conditions we are adding. If the number is divisible by 2, then only we are printing. That percentage d is even. Now look at this. First, what is it? I value 1. Is it 1 divisible with the 2? No. Then I value become 2. Yes, 2 is divisible with the 2. So it will print 2 is even. Next, I value become 3. 3 is not even. Like this. Look at the output. 2, 4, 6, 8, 10. This is what? Printing the even numbers. Just wait. Is printing the even numbers. Next one is, I'm just writing, don't print. Count how many even numbers are there from 1 to 10. Count how many even numbers are there. Don't print. If you find out the even number, count it. 1, 2, 3, 4, 5. So count initially take 0. If you find out that even number, increase the count value. Count plus plus. Count plus plus. Printing that just even count. What is that count? We are printing the count value. How many are there? Just we are printing. Total how many are there from 1 to 10? Only 5 na? 2, 4, 6, 8, 10 count. A very important one, please don't print count inside. Okay, see, just general thinking. 5 even numbers are there. Okay, if you ask count, you are counting 1, 2, 3, 4, 5, and you will give that final answer is a count is a 5. But every time while you are counting 1, 2, 3, 4, 5, you will not print. That is important. Okay. So you need to print count value outside of the loop. Count value outside of the loop you are printing. Next in the same way is a sum value. Sum of events from 1 to 10. So don't use a count variable. Sum variable I am using. If you find out that even number, add to the sum. Add to the sum. Sum equal to sum plus that I. Simply sum of events. Sum of events, that sum is printing. When you run 30, 2 plus 4 plus 6 plus 8 plus 10, you will get the sum. Let me explain clearly all the three once again, because remaining examples based on these three approaches only. Mainly we do either, right? Here it is, either we print, or we count, or we sum. Look at these concepts are same. From 1 to 10, from 1 to 10, from 1 to 10. That's why loop will not change. I from 1 to 10, I from 1 to 10, I from 1 to 10. And every time we are working with even numbers. Print events, count events, sum of events. So the condition also will not change. Loop will not change. Condition also will not change. But only concept is this is printing. This is counting. Count logic inside, printing outside. Same sum logic inside, counting outside. I mean printing outside. Please do, everyone. The question is, here it is. Suppose if I take n value, n equals to 6, one number I am taking. Consider one number. I am repeating the loop 1 to 6, 3, 4, 5, 6. Nothing but up to n we are repeating. Up to n. So every time we are checking, is it 6 is divisible with 1? Is it 6 is divisible with a 2? Is it 6 divisible with a 3? Is it 6 divisible with a 4? 6 divisible with a 5 is divisible with a 6. The given number, is it divisible with 1? Is it divisible with a 2? And so on. We are checking up to, is it divisible with a 6? Nothing but up to itself we are checking. See, what is that 6, 6, 6, 6, 6? Conditions are important, no? N mod. What is 1, 2, 3, 4, 5, 6? I. This is the condition. And this is loop repetition from 1 to n. So now my requirement is what? Display factors. Factors means what? Divisibles of n. Next one, count how many factors of n. Next one, sum of factors of n. Display factors, count factors, sum of factors. Same like previous three programs, you need to write these three programs. First try everyone, then I'll explain. All the three, everyone please try. All the three, everyone please try. Only just here. Condition. Repeating the loop from I to 1. Nothing but 1 to n we are repeating the loop. 1 to n we are repeating. Look at the condition. Same condition I just mentioned. Loop will not change. Condition will not change. Here it is a printing. Is a printing. In the next case is counting. Take the count variable, counting. In the next case, take the sum variable and find the sum. We already discussed. Count and sum you need to print outside of the loop. Outside of the loop we are doing. Please compare with the codes what you have written. Now the two questions. The first one is the checking the number is prime number or not. So what is that prime number? The definition is a number which is having two factors is called prime number. The number which is having two factors is a prime number. So we need to count for the given number how many factors are there. Suppose if I take n is equals to 6. 1, 2, 3, 4, 5, 6. Up to n we repeat. N we repeat. How many factors? 1 is a factor. 2 is a factor. 3 is a factor. 4 and 5 not the factors. 6 is a factor. So count value will increase 4 times. So is it prime number? No, it's not prime number. It's not a prime number. Suppose if you take n is equals to 7. 1, 2, 3, 4, 5, 6, 7. 1 is a factor. 2 is not, 3 is not, 4 is not, 5 is not, 6 is not. 7 is a factor again. So what is the count value? Is a 2. Yes, when count is a 2, we can say that it's a factor. We already know how to count number of factors for the given number. Using the for loop, you please count. Outside the for loop, you please write that if else block. If count is 2, it's a prime. If count is not 2, it's not a prime. Okay. Please write the code. First you try, then I'll explain. Here it is, we are just finding the count for the given count of factors. Loop will not change, repeating the loop from 1 to n. And here it is what condition also we are not changing. Only if you find out the factor, we are just increasing the count value. Just increasing the count value. Okay. Now here we are just, instead of printing the count value, I am checking if outside the for loop. If the count value equals to 2, then we can say that it's a prime number. If not, else it's not prime number. It's not prime number. Is a difference. This is for counting how many factors are there for the given number. Once counting completed, then using if else block, we finalize the logic. If count is 2, it's a prime. See, look at this. If the input is a 6, 6 has how many factors? 4 factors, so output is not prime. If input is a 7, 7 has a 2 factors, so it's a prime. Okay, please do. Compare with your code, everyone. అందులో ఏమున్నాయి నేను తీస్తాను 5 minutes. Okay, now here it is. Now you're asking, look at this. So what is perfect number? First I'll explain, then I'll give the definition. N equals to 6. Repeating that loop from 1 to, look at this. So normally n value is a 6, but question is no need to check with itself. So repeat the loop up to n minus 1, up to 5 only. And then find out how many factors are there. 1 is a factor, 2 is a factor, 3 is a factor, 4 is not, 5 is not. How many factors are there? The factors sum you need to find out. Sum. 1 is a factor, 2 is a factor, 3 is a factor, it's a 6. So the given number and the sum of factors, if both are equal, then it is called perfect number. Simply to say, sum of factors except itself is equals to the same number, given number only. So you know how to find the factors. Find the sum of factors and then compare. Given number is equals to that sum of the factors or not. Please write the code fast. See, we are going to find the sum now. Sum of the factors, no? Sum equals to 0. But a very, very important one, please don't forget, starting from 1, not ends with the n minus 1. You can write either n minus 1, or if you write less than means n. Not less than or equal to, just less than n. Because no need to check with itself. If you find the factor, please do that. Sum is equals to sum plus I. Sum equals to sum plus I. So finally, outside the loop, we are checking if the given number and the sum, if both are equal, we can say that it's a perfect number. Else, not perfect number. Not a perfect number. So when you run the code, if input is a 6, yes, 6 is a perfect number. Okay, please write. Okay, now here it is a one more example. Let me explain. So that is what Fibonacci series is the last example. Okay, is a Fibonacci series. So what is that Fibonacci series? First, I'll show you that series, then I'll write the definition. So starting two values are in the series 1 and 2. Now add 0 plus 1 will give 1. Add 1 plus 1 will give 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 8 plus 13 is a 21, like this. So nothing but here it is, the series in which the sum of two consecutive means what is a side by side. Consecutive numbers sum will be the next number. That is. Just they will ask, how can we implement the code? Take two variables, suppose A, B. For adding C, logic is easy. First take that first two factors directly, 0 and 1 into AB. Just add both and put it in C. So first step is what? Here it is, add A plus B and put it in a C. After that, so what is that C value? 0 plus 1 is a 1. 1. Then in the next iteration, see, A value 1, B value 1. B should come to here and C should come to here. Here it is a 1 plus 1 is a 2. Is a 2. So nothing but B value should come to A. C value should come to B. Into A B value. Into B C value. So next one. Here it is a 1 will come. 1. Next one is a 2 will come. 1 plus 2 equals to 3. Next 2 will come to here. And 3 will come to here. 3 as a value is a 5. So how many times required means what? That loop you need to repeat those many times. Suppose 10 required means what? I less than or equal to 10, I plus plus. 10 times you need to write. Okay. Please write the logic, then I'll explain the final code. Everyone. Okay. Now see that. Just taking that, asking how many factors you need. Or directly I needed 10 factors. Then repeat the loop. N times we are repeating the loop. N times. First you need to fix two values. So what are the values? First factor is a 0. Second factor is a 1 for adding third factor. Here it is C equal to A plus B. Adding them. Then into A, store the B value. Then into B, store the C value. Printing. Sir, what we have to print? See, every time percentage D, just a space I'm giving. Two spaces I'm giving. A value printing. Every time A value starts with 0. Next B value will store into A na. A value become 1. Every time B value is storing. Look at this. Enter N value. Sorry, already given na. 10 directly. 0 plus 1, 1. 1 plus 2, 3. 2 plus 3, 5. N value directly you have taken. Please complete this. These are all for loop programs they're expecting.